Let's do an example from your lab assignment. This is from section 11.8, problem number 1. They want us to find the radius of convergence and interval of convergence for the series. And our series is x raised to the n plus 8th power divided by 8 times n factorial. And our series starts from 3 and goes off to infinity. So we will use the ratio test. Remember, the basic idea is to use the ratio test, find the radius of convergence, and depending on what your result is for the radius of convergence, you can find your interval of convergence by checking the endpoints. So here's the first step, ratio test to determine the radius of convergence. We're going to take two consecutive terms starting with the n plus 1 term. So the n plus 1 term tells you to put an n plus 1 where you see an n. So we have x to the n plus 1 plus 8 becomes x to the n plus 9. And then we have 8 times n factorial. And so we have that 8 sitting outside. And then instead of n, we have n plus 1 factorial. We divide by the regular a sub nth term. And now we're going to multiply by the reciprocal. So the reciprocal is essentially this thing, the numerator times the reciprocal denominator. And the reciprocal denominator looks like it just needs an n factorial. So we simplify this. Let's see the simplification. The 8's would cancel. And the n factorial and the n plus 1 factorial will leave us with an n plus 1 without the factorial. And then here we have n plus 8 x's. Here we have n plus 9 x's. So there's one more x on top than there is on the bottom. So there's that one more x on top that stays there. Now n is going to be positive, and so we can take that absolute value out. X, however, we don't know what x is going to be, so we're going to leave x in the absolute value. It turns out that the x in the absolute value does not have an n associated with it, so we can take that out of the limit because it is independent of the limit. And so now we have the limit as n goes off to infinity. We have a denominator that gets very large while the numerator stays constant, and so that's going to be 0. So our ratio test gives us a result of 0. Now, according to the ratio test, if your L is less than 1, then the series is going to absolutely converge. And it looks like our L is equal to 0 in this case, regardless of what x is. So the ratio test says that the series will converge for all x values for which this limit is less than 1. Since this is true for all possible x values, the radius of convergence is, I think we're going to want an interval here, and it goes from minus infinity to infinity. And, well, your radius of convergence is really just infinity, sorry. And so infinity. So this is a case where it converges for all values of x. And if you have a radius of convergence that converges for all values of x, your radius goes off to infinity. Okay, so that's the problem.